In this video, I'm going to discuss the most tricky question of the AQ exam, A-level physics. So I read the question first and then I will explain. Figure 2 shows how the force F on the steel ball varies with time t when the ball is dropped. So we have a steel ball and we release this steel ball from a certain height and it will go down and it will strike with with the plate on the ground, steel plate on the ground, and it rebounds back. After striking, it rebounds back to the same height. So when it rebounds back, the kinetic energy of the ball after the collision is same as it was before. So it means this is the type of collision in which kinetic energy is conserved, that is the elastic collision. In this scenario, we have the elastic collision, mean the no kinetic energy is lost. So this is the figure 2. As you can see that the force on the ball increases, it will becomes maximum, that is almost 1.7 Newton, and then it will reduce and it will become 0. And the time it took 1.6 millisecond to become the whole scenario is. So actually we are going to discuss that questions first, then I explain. I state the name of quantity that is obtained by determining the area of the shaded area. So the we first question is that we want to find the quantity that we can found by using this shaded area. So shaded area is actually this. You can see that this is a triangle. So we can see that the actually shaded area of triangle, which is equal to half into base into perpendicular or altitude. So half into base is the quantity that we have time, and altitude is the force. So we can rearrange this half force into time. So this is actually half F is the average force multiplied by time. How we can find the average force? Because we know that initial force is 0, after that we have force F, and then after that we have 0. So if we take the average, for example, the force becomes maximum force is F and minimum force is 0. So we take the average. So F average is actually average force is equal to 0 plus maximum force over 2. So it is 1 over 2F. So average force multiplied by time, this is, so what is the quantity? So force into time is the impulse. We know that this quantity is impulse, or you can say that this is also equal to change of momentum, change in momentum. Okay, now we discuss the state the quantity. The shaded area shows the impulse. The quantity name of the quantity is impulse R, and we know that impulse must be equal to change in momentum. Okay, for the number 2, use a graph to determine the initial momentum of the ball. So in order to find the initial momentum of the ball, we just we have just find the half of the area of the triangle. For example, here is the triangle, and we just find the half of the area of the triangle. Half of the area of the triangle shows the initial momentum. So initial momentum is equal to half of the area of this triangle or this triangular region. Half area of the triangle is, we can find the area of triangle by half. We can see from the figure here, half length is 0.8, because 1.6 half is 0.8. So time is 0.8, and force is maximum force is 1.7, that is 1.7. So it means if we want to find the area, so we have half base into altitude. So we get half base is 0.8 into 10 to the power 3, because we have milliseconds. So into perpendicular altitude is 1.7 meter Newton. So we get answer, that is 3.4 into 10 to the power 10 power minus 4 Newton second or kilogram meter per second. Okay, now for the third part, sketch the on figure 3, that is on figure 3 graphs to show the momentum. Where is the time? So we will have to find the momentum time graph, change in momentum time graph for this whole scenario. Okay, for this whole scenario, if you want to find the momentum time graph, so first of all, we want to discuss this momentum time graph must be proportional to velocity time graph. I repeat this. I again discuss this. For example, when the ball is at the highest point, so its velocity, initial velocity is 0. When it goes down, so first of all, let me fix the direction. So I say that downward direction is positive because the ball is moving initially from upward to downward. So I fix this direction positive, and this direction I suppose that this direction is negative. When the ball goes down, it will, before striking the ground, its speed become maximum. Its speed become maximum. So our graph must be because we know that momentum is p is equal to m into v, because as we know that speed is changing, so it means momentum is proportional to velocity. It means the velocity change, so it means momentum changes. So it means the only thing that can change, we can change that the velocity is changing from 0 to maximum. It means, so initial momentum or moment change in momentum is equal to mv. So it means our graph should be like this: momentum time graph or vt graph, they are same graph. So it means our velocity goes increasing, it means the our momentum goes increases. As velocity increases, so momentum also increases. So our graph should be increase, and it will become maximum. It will become maximum. So I draw the maximum at almost, because we know that the time at the time of 0.8, we draw 0.8 here, and so our graph becomes maximum at the 0.8. It will mean the our initial momentum, our momentum must be maximum. So when this ball strikes with the ground and we bounce back immediately, because when it strikes, so there is a negative acceleration because the velocity reduces. Okay, velocity reduces before, after striking it will jump again. When it jump again its velocity is maximum at the initial point. So when it goes at the higher point, it goes move up, so its velocity decreases, and until and the highest point, its velocity becomes 0. So it means our graph shows the like this. Okay, so it will reverse the direction, because as it is coming down, so it is positive, moving towards a positive direction. So now it is moving up, it moving over direction is towards the negative. So it means our velocity or momentum reduces. So until we are at the 1.6 second, time is 1.6 second here, 1.6. So graph look like this. Here initial momentum is increasing trend, then we have a decreasing trend. So this is the graph for the figure 3. I hope it's clear.